Hi, everyone. Thanks for having me. So what on earth does this mean? The whole cloud native thing is a bit confusing sometimes, so hopefully we can figure that out together, maybe. So yeah, the background here is our lovely canonical tire fire. That is basically everything that we think of when we think of something going wrong at this point. But first off, if you want to troll me, reach out to me on Twitter. If you have Twitter, if you're into that sort of thing. You can email me too if you want to talk more at length about these concepts or anything else, and you can find me on the internet at kcwest.com. The slides are up. There will be a link at the end, so get out your phones or whatever for that. And as was mentioned, thanks to Pivotal, they let me fly around the world and meet people like you, give talks like this. I'm thankful to them, so this is my appreciation slide for that. So what even is cloud native? This is a word that's used a lot, I think, these days. Started about a year ago, maybe 14 months ago at this point, that people really started talking about this. There's a foundation for it now, because why not? There's all kinds of stuff. But we could go with this definition, that anything that's old and busted is not cloud native. Or maybe anything that's old or busted, because new stuff can be busted too. Anything that's new and good is cloud native. So this is a pretty reasonable one. I think you can take this to your management and just say, hey, look, I want to be cloud native, so I want to make things that are new and good. It seems logical to me. We could dive in a little deeper, though. I wrote a piece on O'Reilly.com a little while back trying to describe this cloud native future. It's now the present, so the title did not stand the test of time. But I would say, at that point, I said that we sort of take these things together, continuous delivery, DevOps, and microservices, as a collection of good ideas that usually we speak about independently from one another. We have an architecture board over here that's thinking about how to do microservices and building reference implementations that aren't actually real, so they can tell the engineers how to build microservices. And we've got, we're carving out a DevOps team so that they can automate all the things in production for us, and they'll become the experts on how anything runs in production, and then that'll end up getting weirdly siloed, which is strange for DevOps. And then continuous delivery is this release engineering team that's caught in the middle, probably includes QA engineers who just feel like they are the gatekeepers, which is a great source of power, everyone thinks, but to them is this horrible, horrible burden that they have to be shackled to their desks every time we try and do a release until it's completed, because we will never roll back. But I think that instead of thinking about these things independently and making them all kind of awful for themselves and everyone else, we can bring them together. And I think that together this comprises a strategy that we can refer to as cloud native. So I think this is maybe a slightly better definition, although between the time that I wrote this article and now, I want to add one more thing that we'll talk about in a second. But these are basically it. So continuous delivery is our process, our delivery pipeline, the way that we move code from a developer to, or even just the backlog, to production, right? This is the way that we move something through the system. DevOps is a set of cultural practices about how we work together. That's the core thing that I think we should all take away from this DevOps movement. It isn't a particular tool or technology or automation. Like, that's a very fractional portion of what DevOps actually is in my mind. So it shouldn't be everything. And then microservices seems to be a reasonable architectural practice to be able to scale your software and be able to continue to maintain and deliver it effectively. But even more importantly than your software and its architecture is to be able to scale your team and your organization. Because if you've ever had to try and get 1,000 engineers to agree on what's good and should go into production before you do a deployment, you might know that's sort of an intractable problem. And maybe we could cut that down a little bit and just feed people a couple of pizzas, and then magically they can quickly decide what goes to production. That's how two pizza teams work, I'm led to believe, is you feed the team 2 pizzas and then everything's good. That's how that goes. But what is operability? So I was curious about this because we're at Operability I/O, and this is straight from Wikipedia, but it made me laugh and laugh and laugh whenever I read it. Because I think about what we do all day, what I've struggled with, and I'm sure what you all struggle with too, and it's the ability to keep an environment safe, in a safe and reliably functioning condition. But everything that we do, especially when it comes to delivering things onto the cloud, if we're building something for the cloud, we're probably building distributed systems, right? Whether we know it yet or not, we're building things with network effects that we're cramming in the middle of all of our different components. In monolithic architectures, we didn't have those network effects. We had different ways for it to fail. But now we have these network effect ways to fail. And everything that we do is to mitigate failure. We've got the CAP Theorem, and everybody just throws that out there as a way to win an argument in a meeting without actually really defining it or defining the trade-offs we're actually making. We're just like, but the CAP Theorem, so we can't. But what I think is really interesting is that everything we do is in the pursuit of this, but it never feels like it's real. If you go straight to the dictionary, operability is just able to be used, which, good luck. Like, software is hard. Building a system that can be used seems like a low bar, but it's actually a pretty high bar, unfortunately. But I will add to this. I will say used effectively, right? So this is kind of the discussion I want to have today. Is how can we effectively, or build an effective environment, an environment for us to be effective? What's the whole point of what we're doing, right? We want to, in America, like, we're all about maximizing shareholder value, which has worked out really great for us. But what we do want to do is deliver value to customers, right? Delivering on, and actually delivering shipping code to production is the way that we can do that, so that we can get a feedback. We can get the feedback loop going, so we get feedback about whether or not what we built was actually the right thing. When we don't have that feedback, we don't know if we're building in the right direction or the wrong direction, a good direction or a bad direction, since it's sort of a false dichotomy. And if you don't know, then you might be building the wrong thing. There's nothing more expensive than going in the wrong direction. So I'd like for us to try to have an environment and have systems and tools in place so that we can allow the people who are trying to deliver that value to customers to do it effectively. So I would say cloud native operability is a list of 3 things, and unlike most of our lists of 3 things, you actually have to pick all 3 of them. A good architecture. I think microservices sort of fits that bill. There's a lot of things that can be under that umbrella. It's probably the worst name for anything ever in the history of software design and software architecture, but microservices architecture, as we roughly understand it to be these days, seems to be proving effective, and you have companies like Netflix and other companies, mostly Netflix gets all the attention, that are doing this well. Continuous delivery is the process, how we the way that we get code from developers to production. And the culture, we have to have a good culture that supports this. That's what Sarah came up and spoke about before, and she's absolutely right, that without a good culture, you will not achieve success with these strategies. Out of curiosity, is anyone in an organization right now who thinks that microservices are the way they're going to solve all their problems? Just a couple. Who's doing microservices whether they think it's going to solve their problems or not? There they are. Right. So if you're doing microservices but you haven't automated your path to production, how successful are you going to be? If deployment day right now on your monolithic architecture that everybody thinks is ruining your life is the worst day of your life, which for a lot of people it is. It's interesting because I ask folks sometimes, is deployment day a day that you look forward to with glee and happiness? That I'm going to get out to the pub on time afterward and have a drink with my coworkers? Or is it a day that you approach with dread and it's actually the worst day of your life at work? And unfortunately, oftentimes it's the worst. But imagine if you took your monolithic architecture and your application developer started decomposing it into microservices, but you haven't automated your path to production. Then you've taken the worst day of your life and multiplied it by 10 or 20. That seems like a great idea, right? But if you don't have a good culture to support all of this, then you're not going to be successful either. Just one small way that everyone discusses all the time is Conway's Law, that the communication structures of our organization will inform the software and its architecture that we build. Well, it will also inform whether or not we're successful. So if you have 2 engineering teams that can't speak to one another, good luck getting them to speak over an API well. Good luck getting that software to work, because the team isn't speaking, the software is probably not going to speak very well either. So we need all three of these. But I said I would update this, which is that I also think that we need the right level of automation in our environment right now, especially if we're going to the cloud. And I'm going to call that thing, broadly speaking, a platform. Your production environment is a platform right now. It may be in a certain level of disarray comparative to where you'd like for it to be, but that is your platform, because where your code goes to live in order to support your business, support your users, support your organization, that's your platform. And we need a good one. And I think that the production environment that works best in a cloud environment is one that really has all of the automation built in already, so that we're not doing the busy work of building the automation ourselves. So I said pick 4 rather than 3, and I made a list of 4 things rather than 3, so like this is already pretty intense. We really have trouble with lists that go beyond 3. All right, so let's dig into this a little bit. So microservices architecture. So there are some questions people ask about microservices. Like what is a microservice? How do I know if it's micro or not? How do I know if it's a service? Like, does it have to be written in a certain programming language or take up a certain amount of memory? Like, how many lines of code should it be? That's usually the biggest one, right? How big can it be, and what does big mean? So I get, people come at me sometimes, and they're like, well, you know, we have to write our services in Go because then they'll run with a small memory footprint but be highly concurrent. I'm like, yeah, that's pretty cool. And they're like, but if I write them in Java, they'll have a huge memory footprint. They'll still be pretty highly concurrent. But that's not micro because they're real big. And I'm like, microservices aren't for machines, they're for people. They're not. So the other thing that's coming up these days is serverless, or are serverless, insert words here because we don't really know what that is. Are they microservices? Like, maybe. But what's the point of doing this at all? Like, why would we want to consider our software architecture as an important piece of the operability of our overall architecture? And as I said before, I think the real thing here is that microservices are for people, that you can't reason about large systems effectively, and teams that have to reason about large systems tend to make mistakes. And also those teams grow, and then you have, again, 1,000 engineers all trying to decide what should be delivered on deployment day, and that's usually a bad time. And this isn't, I should mention, this isn't universal, and it isn't a panacea. If you ask a specific question about your specific situation, I'm likely to respond first with, it depends. And that's going to be the case. But by and large, we've seen that large organizations are able to break down large teams and large projects into smaller services with clearly defined interfaces and contracts, so that smaller teams can move more effectively, deliver more autonomously, and be able to achieve a higher degree of throughput while keeping the risk that changes will break an overall architecture relatively low. Right? So these questions are usually not the right questions to ask. I think the best answer to what is a microservice comes from someone named Kenny Bastani. He happens to be my coworker. He's written a book that is nearing completion on cloud-native Java. So if you're doing any Java and you want to have the definitive book on microservices, Kenny is one of 2 authors, along with Josh Long, who's written what I would consider to be the definitive guide for that particular stack, if that's what you're into. But he says that a microservice is an application that's small enough for an engineer to reason about it after a day. So if you have a service and an engineer who may be new to it can read the code for that service, understand roughly what it does, maybe make a feature change or fix a bug, and be able to deliver on that within roughly a day, that's probably a good definition of a microservice, because, again, it is for people. And if you're going to decompose an application from one large system to maybe 200 smaller systems, that sounds like something that's insurmountable to manage, and there are a bunch of ways to manage it, and a lot of things that you need to do to be responsible about that. But when it comes to making a change in this piece of your architecture over here, an engineer should be able to go and look at that code, read about it, understand it, and be able to contribute with a very little time. I think that's probably the best definition that I've read, and I think that this makes sense. This is why it's operable, that you can reason about it, you know, and it forces your hand to have smaller batch sizes in the changes that you make. So when you are automating your path to production and you want to deliver change effectively and quickly, if you want to have a mean time to recovery that's in the range of minutes, having something that you can reason about very quickly and make changes on is really important. And that's why it's for the people. The next thing is continuous delivery, which is that process. This is my definition that it's the ability to deploy to production whenever the organization chooses without anyone setting themselves on fire. I'm guessing, I'd like to believe that everyone's been in a meeting where you make a decision about whether or not you deploy. This is obviously pre-automating all that stuff. Has anyone ever been in a meeting like that? Sometimes they're called the go, no-go meeting, but that's weird because I think it should just be called the go or go but be really nervous meeting. Because, or go, it's the go and then pull an all-nighter and then go meeting, right? It's one of these two things, right? I don't think I've ever been in one where we actually say no-go because it's been too risky to the careers of the executives that want to get that stuff to get delivered. But if you've been in a meeting like that and you sit down and you say, all right, we have this stable software, it passed our automated tests, we believe that our automated tests are good enough to give us confidence that we can deploy this thing to production. QA looked at it and pen tested it. The security team thinks it's good. And we want to push this button and turn this on for users. And then somebody stands up and says, I'm not ready. Oh my God, this is going to break everything. And then they proceed to set themselves on fire and lose their minds so that you don't do it because some other team somewhere got surprised. And I think that that's really the most visceral manifestation of continuous delivery breaking down for me. I don't define this to be push to production anytime stable code lands in, say, a master branch, because I would call that continuous deployment. It's a subtly different thing, and it's oftentimes a bit irresponsible. If any of us work in regulated industries or anything with a strong security concern, you'll know that you probably shouldn't just push every time the developer merges something to master. And also, you may need to batch some things up, depending on where you are at in your maturity, until you have a handful of changes that you think are good enough to go out the door. But automating your path to production is really important. Being able to culturally support the notion of delivering to production anytime the business chooses without anyone losing their minds is also just as important. So there are three things that I would say that are really fundamental when it comes to continuous delivery, and this will be a major shift from the big bang once or twice a year delivery if you're in that model now. One is that small batch sizes reduce risk. The risk that a change will break a system. So if you do large batch sizes now in your deployment and you deploy 50,000 lines of change to production, do you know any of your engineers that can reason about what that change is going to do in the production environment when it actually lands? With the understanding of maybe it went through testing, UAT, a staging environment that seems close to production, there are still some major variables there that are very hard to simulate. So you just never know how a piece of software is going to work. And the bigger that change is when you make it to production, the less the likelihood that you understand how it's going to behave is. The shape and size of data in your production environment is a major aspect of your software's architecture. And it's important not to overlook how much that affects the ability for your software to operate as you expect. But what if you only change one line of code and then deploy it to production? I can reason about what that's going to do. That's going to change a color on the front page. 10 lines of code, maybe even 100 lines of code. It's very easy to see and reason about and have a reasonable understanding about what's going to happen when I deploy this thing to production. And that's where the microservices strategy combined with being able to automate the path to production comes in. We also want to decouple deployments from feature releases. So another major difficulty with organizations trying to move to a cloud-native approach is that every time we release right now, which is a couple of times a year, it's always this major feature release. And it's always new functionality going out to users. Have you ever tried to deploy something quickly that maybe fixes a security concern or some other, not that security is trivial, but maybe some other trivial issue and you want to get it out the door quickly, but somebody says, we can't deploy anything to users without marketing and customer success and all of these other teams knowing about it. And if you've ever been in that meeting, it can be quite frustrating because you can look at your code and say, this is not going to change the user experience in any way. I know this definitively. I can look at the code and reason about it. It's a small change, but you won't let me make it because you don't understand that deployments are different from feature deployments. The only way that organizations actually understand it these days is in patch priority fixes, right? Which is incidentally the most agile process many companies have, the most iterative and cloud-like and DevOpsian practice that any organization has is their patch priority, which is where you can get a small change through the door in maybe hours rather than months by basically cutting away all of the parts of your process that don't actually matter when you make small changes, and then deploying with confidence and knowing that you want that code into production. One thing that I'd argue, if you want to be a little cheeky and have a little fun at work sometime, just try and convince your release and QA and operations teams to use the patch priority model that you've developed for all releases, and just do that a couple of times a day and see how they respond. And I think that you have a reasonable case that you do that with relative consistency, and it's a process that everyone has agreed is good for small changes, but you're able to do it more quickly, and it will actually deliver it will give you the ability to deliver faster with reduced risk. But generally speaking, please automate your path to production. In particular, if you're doing microservices or if you have teams, engineering teams who are trying to do microservices, encourage them to work on their deployment pipeline within the very first iteration or sprint or week or whatever you call it in your organization. Get the path to production automated as the first step in any new greenfield project. That way, after 3 months or 6 months of development, when you finally have your MVP and you try and deliver to production, nobody's waiting around for hardware, software, virtual machines, network configuration, DNS, or anything else, right? That's really critical. If you do that first, your project will have a greater likelihood of actually delivering at the end than getting a 3-month delay because all these other teams aren't ready for you. And then we have DevOps, which is, I think, primarily cultural, and you can't buy this from anyone. You can't go to GitHub and download the highest rated GitHub repo for DevOps, and then just install that into your production environment and be good to go. Unfortunately. So who's heard of CALMS? I'm assuming that this audience probably has heard of this acronym before. Collaboration, automation, learning, measuring, and sharing. To me, these aren't actions that we take as much as they are mindsets about how we work. That the people I collaborate and build and be creative with, I want them to exhibit these characteristics in the way they approach work. I want to exhibit them myself, and I want us to be enabled and empowered to do so by leadership. And this is what the DevOps culture really brings to the table. And it's so critical because, as I said before, if we look at something like Conway's Law, well, how can we consider that in a very practical sense? Well, if you do have two teams building services that have to integrate with one another over an API, but they both think that the other are idiots and won't speak to one another, then they build APIs that are incompatible. And that's because the culture is broken. They aren't sharing. They aren't collaborating. They certainly aren't learning together, right? And this is what the DevOps mindset brings to us. And it's why I think it's so important not to build DevOps teams within an organization, but instead to empower everyone to take the responsibility for this culture on themselves in order to own it. Because if you build a team that is a center of excellence for collaboration and sharing and learning together, but you don't share that with the rest of the organization or ask anyone else to take responsibility for these characteristics, then you're going to have a hard time having a functioning organization. You're going to have one small center of excellence that everyone dumps on, who ends up not being very excellent at what they do, and it's really not going to be a good long-term benefit. So I think it's important for everyone responsible for delivering that value to your end user, to the people who use the technology you build, to take responsibility for this. And then the one that I added from the three is good automation, which I would call a platform. And I think this is really important because the place that your code lives in order to service the folks that it's meant to provide value to is just as important in a cloud-based strategy and in an operable strategy. So if production's a tire fire, it doesn't matter how great your process was to get your code into production. If production is the worst place for your code to live, then you haven't reduced risk by increasing throughput. In fact, if you try to increase throughput, but your production environment isn't automated and isn't built for resiliency, then you're increasing your risk by making changes. And that's really problematic. So this is something that a lot of us end up spending a huge amount of our effort on, and I think that's important. And when I use the term platform, I have a specific set, at least a minimum set of capabilities that I think a production environment should exhibit, that I would be willing to call it a functioning, operable production environment. So I like to call it minimum viable platform because it maps to MVP. Now, the issue here that I have with MVP as just a structure is that if who's been in a meeting where you're trying to figure out MVP for something? Yeah, so almost everyone. And how many times does that meeting end up being more about what the minimum amount of effort is required in order to duct tape a bunch of stuff together and make it look good, rather than maybe what's actually a viable strategy? Has anyone else ever had that pain? That's something that really bothers me. So I have 6 things that are on my rubric, and I'll just go through them very quickly. And I think it's a relatively high bar of the automation being built into your production environment already. So if you are in the middle of automation projects that achieve some of these things, then they aren't automated yet. You are automating them. There's a subtle difference there. But you will eventually get to the end of this roadmap where then you have a resilient automated system. So one thing is fully dynamic DNS routing and load balancing. When you deploy new services, they should be available, right? You shouldn't have to send tickets to get DNS entries or poke holes in firewalls or anything. All of this should be automated. If you want to increase the number of instances of applications to be able to handle more concurrent load, then your load balancer should be fully dynamically updatable automatically. And that should be sort of a one command, one click type of thing, right? Backing services brokering, understanding which applications speak to which backing services that make them run, understanding how to connect them over the network, understanding how to authorize them, dynamic provisioning of passwords. No one should ever generate a password manually ever again and email it to anyone else for your production environment. That's not very automated. Infrastructure orchestration, we know a lot about this, the ability to dynamically allocate lower level resources, things like compute, storage, networking. These allocations should be hopefully fully automatic so that developers don't know about them and don't have to go ask for capacity. The capacity should just be made available at the time of need, and this will allow you to dynamically scale responding to load. If you do have good automation there, you can get good health management, monitoring, and recovery. Basically, you can build self-healing systems. If virtual machines disappear in clusters, we should be able to notice that, spin new ones back up, put them back into the pool. Nobody gets paged in the middle of the night. If application instances disappear or crash because, and I've never done this, and I know no one else here has, but if we ever delivered a bug into production that maybe had an unhandled exception, the load balancer should be able to keep up with application instances crashing so we don't route new requests to those bad instances. We need an immutable artifact repository in the great grand world of containers, which who here has heard of containers? Yeah? Who here's tired of that joke? Who's heard of containers? Yeah. Me too. So in the world of containers, we kind of have to build these immutable artifacts. It's a beautiful thing that we have to build them before we deploy them, before we can run them. And there's a life cycle to that has to be respected. And if you do build truly immutable containers, then you end up with provenance. You understand what's actually running in every environment. Your engineers can pull down the version that's running in production, run it on their laptop, and have a good idea about whether or not they're really building compatibility. These are good things. And the last one is log aggregation, because in a distributed environment on the cloud where your cluster is being dynamically allocated, where workloads are being allocated for you automatically, you can't just SSH into every server looking around for log files on the file system anymore, right? We have to aggregate these things and allow them to be drained over syslog or some other protocol to services that we can run analytics and make actionable, intelligent decisions about that information, right? And this one can be kind of hard, but in a distributed system, but it's really necessary. So I think that this is my rubric for what it means to have a production environment that's operationally mature and that can support a microservices architecture with automated delivery to production, with a good culture of learning and sharing, collaboration, measuring the results of the changes that you make. I think that this is super important. So I tried to make this Venn diagram about like what operability is, because I wanted a good visual for you. And I think that Venn diagrams are kind of awful, but maybe the best thing that we have to describe this. So I will echo what Sarah said earlier about culture being one of the most critical things to the success of any sort of cloud-native strategy or an operability strategy. And I want to double down on the fact that trust is so critical. And trust gets broken down over time because developers deliver things to operations folks in a model where you throw things over the wall, you deliver some code to operations, operations tries to run it, it blows up, they go back to development and say, hey, you delivered us this terrible code, and it blew up. And by this point, developers have already decided that operations just doesn't know how to run software, but we've been running it on our laptop for the last 3 months and it works fine. So just give us access to production, we'll SSH in, poke around, maybe change a few things, restart some stuff and it'll be fine. And operations, of course, says, well, no, you keep delivering me crap. Why would I give you more access to a system that you already keep setting on fire? And it just goes back and forth, and this is how trust can break down. And then, folks like us come in and say, well, just sprinkle DevOps on it, and everyone will love each other again, and it'll be fantastic. And somehow that's not always fantastic. Before I learned to try and sprinkle DevOps on it, I would just put my laptop in the hands of the operations folks in the meeting and say, deploy my laptop to production because I can make the software run here. So this MacBook is actually pretty powerful. Just put it in the rack. Because apparently you can't. So turns out that was not an effective strategy, and I don't recommend it. But I think that all of these things are important. Now, culture is I think, more important than the others in terms of whether or not having a good culture versus not having a good DevOps culture influences the success of the rest of these endeavors disproportionately. But as we said before, if you don't have a good culture, you're not going to succeed at sharing enough to be able to have a good architecture. And if you can't share and have a good architecture, then your APIs and your protocols will break down, your communication structures will be reflected there. If you don't automate your path to production, then you can never deploy, and you don't get any speed gains. And if your production environment isn't operationally mature, then your applications are constantly breaking, and you haven't achieved any lowering of risk, even if you've managed to get code that keeps breaking out to production faster and faster. So we can make this more concrete: microservices, continuous delivery, DevOps, and platform. And if you're curious, this is to scale. That little thing in the middle is operability, right? That's how easy it is. So, yeah, super good. Yeah, not a hard target at all. So, this is what I've learned over the course of the last year when it comes to going to the cloud, and especially trying to empower engineering teams, development teams that are delivering line of business value or business value according to some people in suits in some boardroom somewhere. These things are all pretty critical to making that possible. I tried some other ways of visualizing this because I wasn't super happy with my Venn diagram. I didn't think it expressed it well. So I tried this sort of spider diagram, and that doesn't really make any sense. And then I tried maybe a pie chart, but they're not each really 25% important. They're all sort of 100% important. So this bar chart also doesn't really seem to do it justice. So then I just kind of went with this. And you can see that operability is still down there, just as important as ever. But they all really do have to work together. If you have a microservices strategy in engineering somewhere, and it doesn't include the people who are doing a lot of the heavy lifting on your deployment pipeline or on trying to reshape your culture, I would encourage you to get these people talking, because if these strategies, if these initiatives aren't working together, then you're going to have that Conway's Law problem where ultimately they don't mesh up well enough in order to really achieve operability. And if the whole point of this is to deliver things more effectively, that is, with a higher degree of throughput, but lower risk, then you need all of these things to succeed in that. So just to recap, I think you need to pick all 4 of these. However you choose to implement some of the technology here is up to you, and the DevOps culture is the piece that you can't get from GitHub, unfortunately. So, but I do think you need to pick any 4. So we can be friends on Twitter. Again, that's @CaseyWest. We can be friends in real life, which is what that beer emoji is about. So I'm all about drinking that beer emoji. This is the URL to the slides, and hopefully if my automation worked, I'll be tweeting that out, or maybe already did. So in any case, thank you very much for your time, and have a good lunch.